Welcome to NPA Infracon YouTube channel, your destination for quality civil engineering education videos. In today's session, we will see into a case study Thompson v. City of Y Council, 2004, NSWLEC 506, is an appeal against an order issued by the Council requiring the repair or structural alterations to a retaining wall at 49, the Esplanade, Drummoyne. We will be exploring a series of questions and answers to help you better understand the intricacies of this case. We are excited to present this case study to you, and we hope that it will provide valuable insights into the Australian standard and constructability of retaining wall. Make sure to subscribe to our channel to stay updated on upcoming videos and educational content. Let's begin our discussion with your host, Rudy. Stay tuned for an engaging and informative session. Question: what is this case about? This case, Thompson v. City of Y Council, 2004, NSWLEC 506, is an appeal against an order issued by the Council requiring the repair or structural alterations to a retaining wall at 49, the Esplanade, Drummoyne. The main issue in the case was how to classify the wall in terms of structural stability, and whether the wall complied with relevant standards such as AS 4678, 2002 earth-retaining structures, and AS 3700, 2001 masonry structures. The court heard evidence from various engineering experts regarding the design and stability of the retaining wall, leading to the judgment that the wall was structurally sound and the Council's order was revoked. How AS 4678, 2002 earth-retaining structures, and AS 3700, 2001 masonry structures are being mentioned in this case, how two of the AS standards are being used. In the case of Thompson v. City of Y Council, 2004, NSWLEC 506, AS 4678, 2002 earth-retaining structures, and AS 3700, 2001 masonry structures were mentioned in the Council's order requiring the repair or structural alterations to the retaining wall. The order required the wall to comply with these relevant standards, implying that the design and construction of the retaining wall needed to meet the specifications outlined in these standards to ensure structural stability and safety. The court considered these standards in assessing the wall's compliance and structural soundness, ultimately concluding that the wall, while not fully compliant with all aspects of the designated Australian standards, was still deemed structurally sound based on the evidence presented. Question: wall was not fully compliant with all aspects of the designated Australian standards. What does this meaning explain in detail? Or question: which are the some deviations or nonconformities with the standards? Please provide this in details. In the case of Thompson v. City of Y Council, 2004, NSWLEC 506, some of the deviations or nonconformities with the Australian standards, AS 4678, 2002 earth-retaining structures, and AS 3700, 2001 masonry structures, identified by the experts and discussed in the court proceedings include: 1. Lack of substantial reinforced concrete footing. One expert, Mr. Hamilton, noted that there was no evidence of a substantial reinforced concrete footing supporting the blockwork wall. This raised concerns about the wall's structural stability, especially in a high-risk corrosion environment. 2. Uncertainty about vertical reinforcement. Mr. Hamilton also expressed uncertainty about the presence of vertical reinforcement in the wall and details of its embedment into bedrock. This lack of information raised questions about the durability and long-term stability of the wall. 3. Foundation on sandy clay instead of rock. Another expert, Mr. Ottaviano, observed during a test pit inspection that the wall was not built directly on rock but on a sandy clay foundation. This condition was deemed structurally unstable and at risk of catastrophic failure. 4. Lack of detailed construction information. The experts highlighted a lack of detailed information regarding the construction and design of the wall, such as the presence of cantilever reinforcement details, and encasement of reinforcement. This lack of information made it challenging to assess the wall's structural integrity fully. 5. Variability in construction materials. The wall was found to be constructed using various materials, including sandstone, brick, Besser blocks, and concrete, raising questions about the uniformity and compatibility of these materials in providing structural stability. Despite these deviations and uncertainties, the expert assessments provided varying perspectives on the wall's stability and adequacy. While some experts raised concerns based on their observations and analyses, others, such as Mr. Laurie and Mr. Dixon, concluded that the wall was stable and structurally sound based on their investigations and testing. Ultimately, the court considered all the evidence presented and determined that the wall, despite not fulfilling all aspects of the designated standards, was in a low-risk category of failure and therefore deemed structurally sound. Question: Mr. Laurie and Mr. Dixon concluded that the wall was stable and structurally sound based on their investigations and testing. How they derived this? Provide details about the investigation and testing. Mr. Laurie and Mr. Dixon concluded that the wall was stable and structurally sound based on their investigations and testing. Here are the details of the investigation and testing they conducted. 1. Dynamic cone penetrometer survey analysis. Multiple dynamic cone penetrometer test probes were used to identify and characterize the backfill, residual soils, and sandstone bedrock behind the wall. The moisture content of the soil was observed through the condition of the rods upon withdrawal. Observations were made on the surrounding soil type, geomorphology, local landform shapes, and drainage characteristics. 2. Geotechnical investigations. Mr. Dixon conducted detailed geotechnical investigations to understand the construction of the wall and assess its performance. The investigation included modeling and testing various wall design scenarios, considering different fill heights and load-bearing sections. By analyzing the data from the survey, Mr. Dixon identified that the wall was a faced gravity wall reinforced with S16 bars at 400 centers in the vertical and horizontal directions. His conclusion was that the wall acted as a gravity wall rather than a cantilever wall. 3. Analysis and conclusion. Mr. Dixon's analysis showed that the wall was stable and structurally sound, meeting the acceptable risk requirements for a low-risk category. He found that the footing of the wall must incorporate some form of cantilever reinforcing, either cast in the concrete at the base or drilled into the sandstone under the footing. Mr. Laurie reviewed the dynamic cone penetrometer survey analysis and supported Mr. Dixon's conclusion about the stability and structural soundness of the wall. These investigations and tests provided valuable insights into the construction, stability, and performance of the retaining wall, leading to the conclusion that the wall was structurally sound and stable, despite not fully complying with all aspects of the designated Australian standards. Question: Explain the structural stability criteria that are documented complied with relevant standards such as AS 4678, 2002 earth retaining structures, and AS 3700, 2001 masonry structures in this case. In this case, the structural stability criteria from the relevant standards AS 4678, 2002 earth retaining structures, and AS 3700, 2001 masonry structures were considered in assessing the retaining wall's compliance. Here is how these criteria were addressed. 1. AS 4678, 2002 earth retaining structures. This standard provides guidelines for the design and construction of earth-retaining structures to ensure stability and safety. The structural stability of the retaining wall was assessed based on the guidelines and requirements set forth in AS 4678, 2002. Mr. Hamilton and Mr. Ottaviano raised concerns about the wall's stability based on their observations and analysis, highlighting issues like the lack of substantial reinforced concrete footing, uncertainty about vertical reinforcement, and details of embedment into bedrock. They mentioned that the wall was bearing on a sandy clay foundation, which they considered structurally unstable and at risk of catastrophic failure. 2. AS 3700, 2001 masonry structures. This standard covers the design, construction, and repair of masonry structures, including walls, to ensure structural integrity and durability. The construction materials and methods of the retaining wall were evaluated in the context of AS 3700, 2001 to determine compliance with masonry structural standards. Mr. Dixon's investigation revealed the construction types of the wall, including dry stacked sandstone blocks, brick masonry wall, and concrete blockwork filled with concrete grout and reinforced. His conclusion was that the wall acted as a faced gravity wall reinforced with S16 bars, meeting certain structural requirements. In summary, the compliance of the retaining wall with relevant standards such as AS 4678, 2002, and AS 3700, 2001 was analyzed based on the construction methods, materials used, and the stability assessments conducted by the experts involved in the case. The arguments presented by different experts highlighted differing opinions on the wall's compliance with these standards, leading to further investigation and ultimately the determination of the wall's structural soundness by the court. Question: what is the conclusion of court? The conclusion of the Land and Environment Court of New South Wales in the case of Thompson v. City of Y Council, 2004 NSWLEC 506 was as follows. 1. The court upheld the appeal. 2. The Section 121B order made by the Council requiring repair or structural alterations to the retaining wall at 49. The Esplanade, Drummoyne, was revoked. 3. The court found that the retaining wall, despite not fully complying with all aspects of the designated Australian standards, was structurally sound and stable. 4. The court accepted the expert opinions and investigations conducted by Mr. Laurie and Mr. Dixon, concluding that the wall was in a low-risk category of failure. 5. The court noted that there were no visible signs of movement or failure in the wall, contrary to the concerns raised by other engineers, which led to the revocation of the Council's order. 6. The court indicated that there was nothing in the evidence to justify the Council's notice requiring repairs or alterations to the retaining wall. Overall, the court's decision favored the appellant, Mark Thompson, and determined that the retaining wall did not pose a significant risk of failure or safety concern, leading to the revocation of the Council's order. Question: explain the drainage and stability and construction methodology aspects of retaining wall. In the case of Thompson v. City of Y Council, 2004, NSWLEC 506, the drainage, stability, and construction methodology aspects of the retaining wall were key considerations in determining the wall's structural soundness. Here is an explanation of these aspects. 1. Drainage. The retaining wall was drained using several 50 mm black polyethylene ag drain pipes protruding from the face at the lower intersection of the wall. Proper drainage is essential for retaining walls to prevent water accumulation behind the wall, which can lead to erosion, instability, and potential failure. The presence of drainage pipes indicated that efforts were made to manage water runoff and prevent hydrostatic pressure buildup behind the wall, contributing to its stability. 2. Stability. The stability of the retaining wall was a primary concern in the case, with experts providing differing opinions on its structural integrity and risk of failure. Mr. Hamilton and Mr. Ottaviano raised concerns about the wall's stability, highlighting issues such as the lack of substantial reinforced concrete footing, uncertainty about vertical reinforcement, and soil foundation conditions. On the other hand, Mr. Dixon's assessments concluded that the wall was stable and in a low-risk category of failure based on dynamic cone penetrometer surveys and geotechnical investigations. The drainage system, construction materials, and design characteristics all play a role in the stability of retaining walls, ensuring proper water management, load distribution, and foundation support. 3. Construction methodology. The construction methodology of the retaining wall included a combination of materials such as sandstone blocks, brick masonry, and concrete blockwork filled with concrete grout and reinforcement. Mr. Dixon's analysis identified the different construction types of the wall and highlighted the use of reinforcing bars for stability. The construction methodology, including proper installation techniques, material quality, and adherence to structural standards, is crucial for ensuring the long-term stability and performance of retaining walls. Overall, the drainage system, stability assessments, and construction methodology aspects of the retaining wall were carefully evaluated to determine its structural soundness and compliance with relevant standards. These considerations helped in assessing the wall's overall stability and safety in the context of the case.